So our second speaker is a friend of mine, Jason Yee. Jason Yee is the Director of Advocacy at Gremlin, where he helps build more resilient systems by learning from how they fail. He leads the internal chaos engineering practices to make Gremlin more reliable, and he's a true Portlander. He'll be here speaking on validating your incident retrospective.
Thanks, Jason. All right, let's do share screen here. And I think that should work. Awesome. So yeah, I felt like when I saw Jeff was going to be talking about incidents and things, why not talk about incidents some more? So in the spirit of Jeff and storytelling, I'd like to share the time that I broke Datadog. So prior to working at Gremlin, I worked at Datadog, and I did a bunch of stuff there. I was an evangelist or an advocate there, but I also got my hands a little bit dirty with building things and getting involved that way. And so one of the things that I got involved with was the Datadog student pack. So if you're unfamiliar with GitHub, they have a student pack. If you go to, I think it's education.github.com. If you know anybody that's a student that, whether that's enrolled in a university or just like taking a code boot camp or anything like that, it's pretty easy to get access to. And the cool thing is GitHub has brought together all of these different tools, right? Like stuff that's normally super expensive. You get like tons of AWS credits, and now I'm sure like Azure credits since they're with Microsoft, and all these things. And so they reached out to me and they're like, hey, it'd be really cool if students could get some Datadog, because the big challenge is that, well, when you're a student, you don't have access to a lot of these tools, but then you graduate and you're expected to actually be, an engineer with some experience and know how to do things. And from a Datadog perspective, it was kind of like, the drug dealer play, right? Like if you hook them young, they'll get stuck and addicted to it. So my task while I was at Datadog was, cool, let's integrate with the GitHub student pack, give people free Datadog. And the process was pretty simple. Users basically OAuth into GitHub. That sends them our way, or sent them our way to Datadog. And then I basically wrote a little bit of code. And I'm not the best coder, but it seemed pretty straightforward, right? Like the way that we designed it was within Datadog, we had one master account, and then you would sign people up and they'd be essentially sub accounts under this master account. So you could essentially leverage that master account, and any permissions or sort of features that you enabled there would trickle down. And we did this all the time for enterprise organizations, right? You have a giant bank and they've got 500 different teams, and they're like, well, we want one billing for this, right? We want the master account, but we don't want the customer banking team to have access to the infrastructure information for, say, the securities trading team. So it kind of makes sense. So the code that I wrote was this, right? This is basically the pseudocode for it, but you have the master account, so you have an API key for it, right? You grab that from some secure location, and you use that then when a student hits the registration page, use that to create the student account, right? So now the student has a child account that's under that master account. And once that's done, then you essentially switch users to that student account, or you get the API key for the student account, and you use that to do everything else. All the accounts set up, you create the user, you send the email to that user. It's pretty straightforward, right? I'm not the best coder, but again, like this is totally, I can handle this. So we did this and decided to roll it out. And we deployed it and we announced it, and something went wrong. As I guess, again, I'm not the best coder, so maybe I should have expected that. So we ended up, we halted it. We threw up a quick splash page that was like, hey, this isn't working. We do a quick, sort of troubleshooting type of thing. We run, essentially not quite a full postmortem or incident retro, but we basically, spend some time and try to figure out where Jason screwed up. So the fun thing, if we look at this, is I used Green Unicorn, or Gunicorn, as I like to call it. And the gist is this, that essentially routes are kind of like loops, because Gunicorn has threads. And so it just keeps that thread open and reuses it. So it's essentially a loop. Every time somebody hits that page, it's just going to run this, and it doesn't restart. It doesn't repull the master key. And so since we were reusing the key and resetting it, essentially when it tried to run the second time, the first time it worked, right? So in all of my development testing, you run it like, cool, this works. You push it out into production, suddenly like every subsequent account or every subsequent request is using the wrong key. And so that throws an error, and yeah, it's all that fun stuff. So you quickly realize like there's awful things when it comes to running in production. So it would pull that, and again, that creating the student org, it would just essentially barf there. So that's cool. Like, I mean, you're thinking about that. If this is essentially a loop, it's a simple fix, right? Don't be clever and reuse the API key. Like actually or reuse that variable, just like set a new one, student API key rather than master one. Great, now we run this, the master API key always stays the same. The student API key always gets reset when a new student account is created. The code works. We actually test it, and we test it multiple times with a couple of users, and to ensure that Gunicorn's threads actually work the correct way. And then we go and deploy it again. Did I mention? I don't know if anybody noticed this on this page. There are a lot of users of this. So there's, well, at this point on Twitter, they have 73,000 likes. They have like something like 200,000 users in the program. So when we launched this, we actually got about 15,000 requests, I think, within the first hour. So if you're thinking, well, Datadog's a SaaS product, this might be a problem, you'd be correct, right? If you run a SaaS product and your account creation API is out there, you should probably have a rate limit on it. I mean, that's basically how you make money, and you want to prevent abuse of your business. Except for in times like this, when you actually do have the announcement of a new feature that causes a bunch of people to register. So yeah, we had more issues. So we hit rate limits, obviously, on the API. We also hit latency as the system created accounts, because nobody had designed Datadog to handle massive amounts of account creation, right? Datadog's designed for like massive data ingestion. Like, yes, send us all your metrics, send us huge amounts of logs, but don't create 15,000 accounts all at once. So this caused weird things. I like that Jeff mentioned that there were no timeouts on his application. We did have timeouts. Unfortunately, they weren't tuned at all. So this meant that when somebody went, and if they actually got through because we weren't rate limiting, the account request creation would get queued, the website would time out, the account would still get created, but the user would get told that their account wasn't created, which would then prompt them to try again. And that would send another request and start this whole thing. So yeah, basically now, rather than just 15,000 people trying to create accounts, we had 15,000 people repeatedly trying to create multiple accounts. So yeah, that was a good failure. And even actually, so we ran this, we did another postmortem. What could we have done better? What can we fix? How can we update Datadog's backend to handle things like this? Even with all that, a year later, or about a year and a half later, one of our teams was building a new feature, and that happened to generate a graph of user relationships. And the funny thing is, nobody had counted on the fact that at that point, there were like 40,000 child accounts under my account. And because of the way that graphs work and relationships, it created like, 1 billion connections, and it crashed Datadog again. So I no longer work at Datadog, not because of that. Thankfully, they never fired me. As Jason mentioned, I now work at Gremlin. I do a bunch of stuff. I really have this slide just to say that I'm on Twitter. My DMs are open. So if you ever want to chat about stuff, feel free to DM me or send me an email. That said, I do work now at a company called Gremlin. Gremlin, our main goal really is to help you proactively improve reliability. So I'm not going to talk too much about Gremlin, but if you're interested, gremlin.com/talk/Seattle DevOps. That'll get you some more info. And there's also an ebook on reducing mean time to detection. So that's kind of a cool little resource. But I say all that because I want us to do chaos engineering, right? And I'll connect these two in a bit, but in case you're curious, chaos engineering, we often think of things like chaos monkey and random destruction. And I wanted to say that chaos engineering is not that. So the company line that I'm supposed to say is that chaos engineering is thoughtful, planned experiments designed to reveal the weaknesses in our systems. And it's a nice little catchphrase that we use. And again, it's the company line, so I'm supposed to say it. It's short, it's memorable. It plays into that idea that we don't want weaknesses. We want strong, reliable systems. But the more that I've thought about this and the more that I've actually helped people run chaos engineering, both inside of Gremlin and with customers and other organizations, I've realized that it's a bit more of this, right? It's not actually about our systems. So the thoughtful planned experiments part of chaos engineering is definitely correct, but it's really there to improve our understanding of how our systems work, right? Because ultimately chaos engineering is about learning, and learning how our systems work is much more useful because our systems are only as reliable and only as resilient or strong or robust or efficient or performant as we can make them. And that requires us as engineers to have that knowledge, to have that perspective. And if we don't, if we're not learning things, if we don't understand how our systems work, then obviously we can't make them better. So all that said, chaos engineering is an experiment. So it follows the scientific process, right? If you remember from grade school, scientific process is number one, have a question, right? Observe your system, have a question about how it works. Number two, create a hypothesis. How do you think it works? What's your theory on this? And then with that question, you create some sort of test to try to validate whether your hypothesis is true or not. With that test, you start to analyze the data, figure out if it actually holds up, and then you share the information, you share your results, and you repeat this in a process, right? Or in a cycle. Pretty straightforward. So when it comes to chaos engineering, you follow the process. So number one, the question is my app or system reliable? Or at least that's a question that I think most people want to ask. But again, remember that chaos engineering is about learning. It's about trying to understand our systems. So rather than, is my app or system reliable, the question is, does my app, does my system, or when it comes to our incident retrospectives or postmortems, do the fixes that I've worked on or identified, do they work the way that I think they do? Do they do the things that I think they do? Do they operate how I think they do? From that, then you build that hypothesis, right? My hypothesis is, I think it works this way. I think it will respond this way. So given some condition particularly around failure, I think my app will have this reaction, or I think my system will have this reaction. And the testing then becomes to inject that failure or replicate that condition. And then obviously you analyze that. What did you learn? What can be improved? Did this actually work the way that I think it did? And if not, can I bring my mental model into alignment with my system? Or are there more additional fixes to bring my system into alignment with my mental model? And then obviously, again, the important part of science is to share your learning, share what you've learned about your systems, share what you've learned about your processes, and repeat, continue to iterate. And so I bring this up because when it comes to incident retros or postmortems, how do they usually go, right? If you're in an awful organization that does like blameful postmortems, then the retro is often, this is the root cause. We asked 5 whys. We ended up with this root cause. We made a fix, and that fix was to fire Jeff because he made a mistake. And it will never happen again because Jeff doesn't work here. And then it does. And you're like, who do we fire next? Or maybe you're a better organization and there's no such thing as root cause. But we found 5 things and we made 5 JIRA tickets for them. And those tickets got complete. And so this thing will never happen again. And then it does. Right. And so you have these issues. Well, okay, I've got a better solution. We've practiced this a bunch. We're doing blameless postmortems. No such thing as root cause. We found 5 things. We made 5 tickets. We added tests, right? So we have tests in our CI pipeline. This will never happen again. And yeah, and then it does again, right? The problem that I find is that we take an incident and we work down to the problems that contributed to that, particularly the technical ones, because we're engineers and we focus on that. And we build solutions for those problems. But we rarely work all the way back up to ensure that solving those problems actually prevents that incident or mitigates it or resolves it in some way. And so I think the solution here is we've got to replay the incident, right? We've got to go back and say, well, if these were all the contributing factors and we think we've solved them, let's try to put this all in play and see what happens when they come back together. So let's rewind back to that incident that I created, right? I launched the program. I'm getting a bunch of user complaints. They're seeing 500 errors, they're seeing them on the front end. I'm seeing them on the back end in my monitoring tool. We put up that static page saying, sorry, we're unavailable right now. We go to debug, we run that retro to see what we should fix, right? And it comes back to this. This is normally where we stopped, right? We stopped, we found the issue. The issue was that I was trying to be clever and reuse that API key variable. And so the fix was to just not reuse that API key, right? And so normally in our incident retros, this is the JIRA ticket. Cool, I just went and did it. Maybe I wrote some sort of test and we do a bunch of testing and cool, now this is done. And this is exactly what we did and we redeploy it. So rather than calling this done, let's replay that incident, right? First in staging, then we'll work it up into production. We'll use some fake traffic. And had we done that, well, then we would realize like, cool, not quite done, right? Let's hammer it with 15,000 fake requests, generate that traffic, see what actually happens rather than prematurely deploying, see what else could happen. So short talk, but really drive this home. Fix incidents, not just the causes. As we're starting to do incident retrospectives, as we're starting to do blameless postmortems, we're going to break it down into those causes. We're going to break it down into contributing factors, and you're going to solve for those. But ultimately, you're not trying to solve contributing factors. You're trying to solve for larger incidents. And so you have to work your way back up. And so I think using chaos engineering, using a framework to inject failure and recreate those incidents and actually test them in a holistic manner is really what you need to do before you call something truly fixed. So with that said, I will open it up to questions and happy to chat.